In the early 1930s, Swiss-American astronomer Fritz Zwicky had a problem. Observing the galaxies in the Coma cluster, Zwicky concluded that they were moving so quickly that they should be flung into space, yet they remained gravitationally bound to this cluster by something unseen. Eventually, in 1933, Zwicky hypothesized that there must be some elusive yet pervasive form of matter that keeps the universe ticking, and he called that substance dark matter. In the ensuing century, dark matter became a kind of go-to explanation for inconsistencies between theoretical conclusions and experimental results. While powerful techniques, such as gravitational lensing, have recorded indirect evidence of dark matter, no one has ever successfully directly seen the weakly interacting massive particles, or WIMPs, as the leading dark matter candidates are called, that comprise the substance. Some physicists have become so frustrated with this lack of confirmation that they've gone searching for other explanations, whether re-evaluating the role of information in the universe or diving deep into theories like modified Newtonian dynamics. Now, however, a new study published in the Journal of Cosmology and Astroparticle Physics hopes to put these concerns to rest. Led by Tomonori Totani from the University of Osaka in Japan, the study reports the direct observation of specific gamma-ray photons that are hypothesized to be the results of two WIMPs colliding and annihilating. Totani found these halo-like structures by analyzing data from the Fermi Gamma-ray Space Telescope, which was launched back in 2008 with the mission to study the high-energy universe. This inevitably pointed the telescope toward the Milky Way's center, where all that high-energy physics unfolds. Over the course of its work, the telescope has made some incredible discoveries, such as the giant gamma-ray bubbles known today as Fermi bubbles. If Totani's observations can be independently verified by other astrophysicists, the telescope will add another incredible feat to its already impressive space-exploring resume. We detected gamma rays with a photon energy of 20 gigaelectron volts, or 20 billion electron volts, an extremely large amount of energy, extending in a halo-like structure toward the center of the Milky Way galaxy, Totani said in a press statement. The gamma-ray emission component closely matches the shape expected from the dark matter halo. These observed energy spectra in this data suggest the annihilation of WIMPs, each with a mass of around 500 times that of a proton, which is within the window of theoretical prediction. Totani also stresses that these emissions can't be easily explained away by more common astronomical events that produce such emissions, strengthening his argument that this is indeed an observation of dark matter. If this is correct, to the extent of my knowledge, it would mark the first time humanity has seen dark matter, Totani said in a press statement. And it turns out that dark matter is a new particle not included in the current standard model of particle physics. This signifies a major development in astronomy and physics. Of course, extraordinary claims require extraordinary evidence and rigorous verification. Even if Totani's results pass this high bar, scientists will want more examples of this phenomenon from elsewhere in the universe, and will search for similar gamma-ray emissions coming from, say, dwarf galaxies within the Milky Way halo. Some of this data could come from Fermi itself, or the upcoming Cherenkov Telescope Array Observatory, which will study cosmic phenomena by analyzing gamma rays that interact with Earth's atmosphere. For now, the search continues, but dark matter is quickly running out of places to hide.
So that was all for today's video. Let us know what you think about it in the comments section, and subscribe to our channel so you don't miss out on our latest uploads. With that said, we will see you next time. Until then, take care.